Anyways, this is 5.4, and I'm just giving you some hints. This is question number 1. They give you a table, and they tell you to estimate, and I'm not going to write all this down, but they tell you to estimate this integral, this f of t dt. But what they've given you is a table of values. So you have all these values. So to estimate it, you're going to do this long way again. You're going to do a left-hand side. You're going to do a right-hand side. Remember, that's like this versus like that. And then you're going to average them. So that's what they mean by an estimate on that one. If you kind of get stuck on that one. I think the only other one that you might have an issue with, just because it's kind of horrible, is the last one. They give you 2 graphs, and these are heights. I don't even remember what they look like, but say this, and these are heights of women and men. And they ask you to find area. The problem is how they want you to find it, is this is a grid. And so basically what you have to do is start counting squares. Yeah. That's how you find, they don't give you a function.
Or you could just press, you could submit the answer like 5 times and find the solution.
Okay, or you could, so now we know how Justin does his homework. And they ask you which one is the males. Well, of course it would make sense the males would be taller, so that's that one. I think 5.4, you should already have that one finished, right? So that ain't a big deal. We pretty much worked all of 7.1. Well, some of us did, but then some of us came up here and made fools out of themselves, and they didn't. Oh, was I looking in your direction? I'm sorry. All right, so, yes? Hush.
The last one on 7.1, we took the antiderivative, and then we substitute the c with the...
That was the marginal cost one, yes. So then the fixed cost, you substitute the c with.
Okay, so it would be the antiderivative, but what do we, what is it equal to?
Total cost, not a number.
Okay, so it's equal to 0?
Because that's the one that was weird, that it had c equals the antiderivative.
Yeah.
And this was one Justin said, why are they using c? And then plus c. This c means for the cost.
The one that we're finding.
Yes. This c is your fixed cost, the number they give you, and you just plug in.
Okay, so we bring the fixed cost over.
Nope, just leave it just like that.
Oh, submit it like that?
And then just put plus that answer. Yeah, you don't have to solve it. Oh, you were setting it equal to 0 and trying to, good gosh, wasn't it like a quadratic? Good luck with that one.
Yeah.
Give it to Ben, he can solve it. Yes,
One more on 7.1.
Okay.
The one that was 9x plus 1 over the square root of x. Can you tell me how to do that one?
Wait, hold on. What number was it? 9x plus the square root of...
Like 27, 28. It was after 26.
Okay, read it to me again, because I don't have anything.
9x plus 1 over the square root of x.
And they want you to find, and that's it?
Yeah, antiderivative.
And they want you to find the antiderivative. All right, so what, gang? What's the antiderivative of 9x? Couldn't you rewrite this as, let's do it in steps. Yes, so in other words, if I bring that to the top.
I figured it out.
So you see, Kyle, what I did is I made this the 1/2 power. You're okay with that? Then I brought it up here to the top because now I know my rule says to add 1. Right? So that's my rule, is to add 1 to the top. And so I'm going to end up with x. So in other words, that's like 2 over 2 to the 1/2 over 1/2. Is that okay? Okay. And so then this, of course, would be the same thing as the square root of x, and I could bring that 2 up to the top, and so we get that. So in other words, I did lots of steps, right, to break it down, to make it look like a power rule that said, well, that's the same thing as x to the 1/2 power. I can bring it to the top. It's the same thing as x to the minus 1/2 power. I add 1, and so whatever I do to the top is going to be the same thing on the bottom. So I have x to the 1/2 over 1/2. I can flip this and bring the 2 up top. X to the 1/2 is the same thing as the square root. Is that okay?
Yeah, I got lost that last time.
Yeah, that's a good question, actually, to know what to do with that piece right there. Yes? Yes?
I was gonna say, so is it 2x or 2x to the 1/2?
It could be 2x to the 1/2, which is the same thing as 2 to the square root of x. Because x to the 1/2 is the same as the square root of x.
The plus be needed.
Yes?
For number 18, how do you see the derivative of fraction?
So, hello. So mine looks like this. So is this kind of what yours looks like?
Yeah.
Okay, so that you do this, and I heard you say take the derivative of? The there you go, okay. So basically, we're doing this again. Just do the same thing. So, and let's do this the long way. I'm adding 1. I could pull that 1/6 out front, so that gives me that. And then this would be like to the first power, so that would give me that. Yeah, anytime you can, and I actually found this out in my engineering calculus class, it bothers them, things like that, because like you said, it's a fraction. Pull that fraction out of there and just ignore it. You know, and now you can just finish this, so you'll have what, t to the 10th over 10 minus t to the 7th over 42,
Yeah.
because you're going to go ahead and multiply that, and then t squared over 2. Is that okay? Okay. Sometimes I look at you guys and you're just looking at it like, I still don't get it. But you got it. You're okay. Okay. All right. So, and as you saw, there's lots of 7.1 questions. So, yeah. All right. 7.2. Just some that I kind of picked out. And 7.2 is substitution. I don't know why I starred this one, but might as well write it. Okay, so now we're to 7.2, which is substitution. And this is number 14. And it looks like this. dy.
This one.
Yeah, so that's just a little weird from the way you're used to seeing it. So I probably would rewrite it as 1 over y plus 6 dy. I mean, that means the same thing, right? But I don't know really what to do with this, and it's kind of nice. It's in 7.2, so that means, are y'all going to yell at me if I use a w? What's w going to equal? Y plus 6. I need more room. So what's dw dy? What's that derivative? 1. So 1, and then I'm going to multiply both sides by dy. So as you can see so nicely, that's that piece right there. So I could rewrite this with substitution as 1 over my w, and then in terms of dw, so I'm substituting my dy as dw. And I know now, I remember now the reason, and I should have thought of you, why I'm doing this one. So what's the answer?
Natural log of the absolute value.
Thank you. You will get this wrong if you put this.
Which is still, I still think that's the answer. Plus c.
Yeah. You have to put the absolute value bars in there. Okay? Because once again, if you remember, logarithms look like this, and you can't have negative values inside there. That's a little picky, you know. I would think they would still give you credit for it and say, really, you should put that, but
They don't really stress it.
all right. 21. Again, some of these I question. Why do I have them starred? But it could be that maybe you wouldn't be sure what to pick for your W or your U. So cosine 3t. Oh no, I do remember this one. Sine of 3t dt. Excuse me. What's W? I heard somebody say cosine. I like that answer better.
No.
What's dw dt?
Negative 3 sine
All right, everybody's okay with that. We take the derivative of cosine is negative sine, and we take the derivative of the inside, which is that 3. Okay, so and then once again, I look at this and I say, well, let me go ahead and write it like this. dw equals minus 3 sine 3t dt. And I look up here and I say, ooh, that looks good. Ooh, that looks good. That doesn't look good. So I divide both sides by negative 3. And now I have exactly what I want to substitute in. So that gets substituted, or I should say that gets substituted. So I think it was probably the negative is why I thought this one might have bothered you. And so I have here, now notice, Kyle, this is going to be just like yours. I have the square root, in this case, of w. All this stuff here I'm substituting with a negative dw over 3. I probably would bring that 1/3, because that's what that is, out front. And this is why I said this is one like yours, Kyle. I would write that as to the 1/2 exponent, dw. And now I have something that I know what to do. So I do my plus 1 thing. So minus 1/3 w to the 1/2 plus 1 over 1/2 plus 1. And of course I get minus 1/3. So that's what, 2 over 2, so 3/2. Now I'm going to do that crazy fraction flipping thing. And a lot of students, most of you just memorize the 2 comes to the top. But I tell you, there's never anything wrong with going old school, is that what you're doing is you're dividing a fraction. When you divide a fraction, you flip and multiply, right? So that's really why you're saying, well, that's going to the top. So I'm going to end up here with 2w to the 3/2 over 3. So again, however you want to say it, I brought that 2 up top, which gives me minus 2/9. And eventually, I need to plug in, sorry, you can't see it. Eventually, I need to plug in my w back in, so let's just go ahead and do that now. So that's cosine of 3t. That was supposed to be a 3, not a w, to the 3/2. So as you can see, this last step, I took my w and I substituted back in that piece. And that's some of the errors I see some of you guys make when you get these wrong, is you forget to substitute back in, at the very last step. So definitely work on these substitution ones, because one, as you can see, they take a little longer. This is 23. It has sine to the 8th power theta cosine theta d theta. What would you let w equal? Sine. So let w equal sine of theta. So I'm going to quit writing dw over d theta. I know I'm going to move the d theta to the other side. So the derivative of sine is cosine. And then, of course, I have d theta. Well, that's lovely. That's there. So I start my substitution. My sine is w. I need that 8th power. And then dw. So once you got this step, this is actually a very easy problem, right? Because that's just w to the 9th over 9. But it was figuring out which one of these would you use for your substitution, okay? So again, w to the 9th over 9 plus e. And then finally, your last step, sine. Remind me, Vivian, where did you put the 9? Did you put it right there?
No, you couldn't do
You
that.
gotta-
You had to put it outside, okay. Yeah, because we were trying to figure out where to.
Still works though with the.
Do you have to do that? I didn't care about the brackets.
I didn't put brackets, I just put it.
You just put it on, okay. Over 9 plus c.
What do you do with the 8 on the sine to the 8?
So I substituted w, right, for sine, so that becomes w to the 8th.
Oh, yeah, okay,
Yeah, so then I do my antiderivative, and then I just plug the sign back in. So as you can see, it's a lot easier to do that way. I don't know, the substitution ones may take you a little longer. How about one like this? That's why I was really hoping you would have probably all of your 5-4 and 7-1 done by now, right? You got all of Sunday. Why would you do them by now? All right, this is still 7.2. This is number 35. This is just stuff with e's. So this is e, and this is all an exponent to the square root of y over square root of y dy. You always look at my engineering calculus class, and they're all working like 10 o'clock Sunday night and texting me, can you do a video? Is that you? It's like, can you do a video? I'm like, no, I'm watching football. What's wrong with you? So what's W? Yep. Or once again, you could write this. I don't really want to write this as y to the 1/2 because I'm hoping that you've gotten this down, that this square root is 1 over 2 square roots of y. Jace? You remember that one? You got that one down? So I look over here and I say, well, that is that. So I have a problem with a 2, so I just multiply both sides by 2. And then that way I get my exact thing I want to substitute. So substituting away I will go. So I'm going to have e to the w times 2 dw. That one's kind of weird because you're like, well, what happened to the fraction? Well, this substituted, that went away. And all of that became that right here. Okay, and then I substitute that in. And so, of course, this could be rewritten like this. And what's the antiderivative of e to the w? E to the w. Woohoo! And so then, again, your last step is plug in what your w equals. All right, 7.3. 7.3, number 17. So the only thing that changes with 7.3 is now you have numbers to plug in. It's fundamental theorem of calculus stuff. So this is from -1 to 1, cosine t dt. Now, most of you probably would look at this and say, why is she working this one? This was an easy one, but there's actually a little trick to this one. So what is the antiderivative of that? Sine of t. And remember, these are my values. Well, Justin likes brackets, right? Those are my values that I'm plugging in. So that means this equals sine of 1 minus, we don't care, sine of -1. My question to you is, what is that? I don't want a number. I don't. Okay, I don't want a number. Do you remember a thing about even and odd functions? Is that function odd or no?
That was in high school.
Okay, so this is an odd. It looks odd, right? An odd function, which if you remembered that, that says you bring the negative out front. Oh. And so you end up with the sine of 1, negative, and a negative. And this is just how you leave your answer. But this is how you actually get that answer, is you would have had to remember that. And I didn't figure many of you remembered it. It's been a while. Yeah. And, well, I guess if this one wants exact values. What did you put for your answer? Oh, so you had a different question. So you're oh, you left it like that?
No, the on top one.
That one?
Yeah, something like that.
Really? And it took that answer?
Wow.
I'm going to go in and change that. Yes, Raphael. You forgot your question? Oh, no. Why do you not do plus C?
Oh,
Because it's
you're having.
I'm trying to get y'all to get the word. It's a definite integral with the numbers.
Yeah.
She's drawing things in the air. All right. You know what it is. It's always funny when I'll ask students, we'll go through and we'll say, you remember, a line, you remember a quadratic, and they'll do that. And then you remember a cubic, and they'll do that. And you'll go, and you remember an absolute, and they're like, victory. Like, yeah, okay. You start drawing in the air too much. All right, number 30. Find the exact area. Who was that, Corey, that came up here and said, there it is, it's right there. Find exact area. I'm telling you, there's two lines at this college. There's you are a normal student line, and then there's put you in Cindy's class line. So I would question your normality.
There you go. I like that.
A lot of them are like violators, so that's why,
What's math?
Of the region bounded by the, I was about to have a heart attack. I thought I didn't have the record button on, but I do. I'm good. The x-axis and the graph. Shh, Justin, I don't want to hear you talking. Of y equals, Raphael, I don't want to hear you laughing. Chris, I don't want to hear you breathing. Somebody just threw their calculator, as long as it wasn't at me. All right, so find the exact area region bounded by the x-axis. I know what an x-axis looks like. That would be, yeah, me too. That would be an x-axis. Woohoo! And then I would graph this, and if you graph it, what you're going to see, or you don't really even have to graph it, you could just simply find the x-intercepts, which are going to be -1 and 1. So this is what you're looking for. You're looking for this area. Amrit, did you get that program to work?
No.
Did it load? No. Okay. This is where you pretty much on homework, and we did figure out how to do this with a calculator. So if you have a calculator, you can find these areas with your calculator. We're going to do it the long way because, I'm going to make you show work. But you could check it. The only thing you have to be careful of is remember this is going to be negative area. And so what you have to do is when you find this area, just absolute value it. So what we're going to do is we're going to split this integral up from -1 to 0, okay, of this function, x cubed minus x dx, plus, and we'll just absolute value it later, the next interval from 0 to 1, x cubed minus x dx. All right, so away we go, antiderivatives. What do I write? There's a fourth over 4 minus x squared over 2. Okay, so that's from -1 to 0, plus, it's just the same thing, right? X to the 4th over 4 minus x squared over 2. But that one's being evaluated from 0 to 1. And now you just start plugging in numbers. So if you plug in, let's plug in our top part. So this is going to equal 0. I'm going to go ahead and write, I know it's 0, but let's just plug in everything. Is everything okay, Ben?
absolute values.
Eventually, what he's saying, I got to do that, right? That, yeah. I'm going to do it at the end, yeah. And so I'm going to go ahead and plug in every single one of these values. Even though you know that's going to be 0, I'm just going to do it to remind you, if that wasn't 0, you got to plug that one in. And so that's that. Now I'm going to plug this one in, so it's minus -1 to the 4th power over 4 minus -1 squared over 2. Now I got to do this side. So plus, that's that plus right there. Now I'm going to plug in that 1. So I'm going to have 1 to the 4th over 4 minus 1 squared over 2. minus, and I'm going to plug in the 0. 0 to the 4th over 4 minus 0 squared over 2. Okay, I just wanted to do one of these complete, so when you don't have zeros, you know you got to plug all those numbers in. Okay, so plugging all this stuff in, just don't get lost with that negative sign. So this is 0 minus 1/4 minus 1/2 plus 1/4 minus 1/2 minus 0. And so now down here, I'm going to get the negative of 1/4. Let's get common denominators. Plus 1 over 4 minus 2/4. And so I'm going to get minus a minus 1/4 and then plus a negative 1/4. So as you can see, if you did not absolute value this, you would get 0 because it cancels it out. So this is where Ben was saying, wait, absolute value this. So if I absolute value, then I get 1/4, and bless you, and then I get my final answer. So this would be something that you could check with your calculators, either by splitting it up like this or just doing 1/2 of it and then know you're just going to double it. And the only reason that works on this one is because of our graph. This was the same distance here. So don't think that all the time. Well, all I have to do is do one side and then double it. It's just so happened our graph was symmetric, okay, for that example. All right. This one's kind of weird. So this is 32. It says f of x equals 10x between x equals 1 and x equals b. And it says that's 120 where b is greater than 1. And it's like, what am I supposed to do? So basically I'm going to figure out what this antiderivative is first. And so if I find this would be what, 10x squared over 2 or 5x squared. So that's my antiderivative. This is telling me my interval, which is saying that I'm going to evaluate this from 1 to b. So I just do it the normal way. I just plug in, even though it's kind of weird with that b, I just still plug that in. Then I plug in 1. And then it says this is 120. So this equals 120. Are y'all okay? You got it? You got it? Okay. And so all I did here was plug in 1. I plugged in b to my function. I set this equal to 120 because they told me that. And then I just simply solve this. 5b squared minus 5 equals 120. 5b squared equals 125. B squared equals 25. Technically, you should be doing, and I know we're getting out of the habit of it, but when you square root both sides, technically you should be doing plus or minus. However, right here says since b has to be greater than 1, then b must equal 5. So basically what you're doing, you're finding the value of the upper limit of this. They've told you the area, and they've told you the lower limit and the function, and they want you to find this upper limit. All right, 35 is kind of nice because we get stuck doing these and you kind of lose track of what are we doing. And this one's kind of nice because it's a word problem. Is this says that the population, and they give you this function, 6.1 e to the 0.012 t, where t is years since 2000. And so this is just a population function. Part A says to predict the population in 2015, and then it says to predict it in 2020. What do you do?
Plug in.
Plug in what?
The
15. Yeah, so that's why I made sure you saw that. So plug in 15, plug in 20. Up here, I get 7.3. This one, I get 7.8. Part B is actually, I don't have my syllabus. It's actually a section, I think it's 6.1, if you want to find it in the book. It's to be able to average an integral, and the formula is just this. And which should make sense to you, that says, well, I still find my area, and how do I find the average? Is I divide by the size of my interval. And so that's all that piece is doing there. So meaning, if I did this, I would get 1 over 15 minus 0. Oh, I didn't write the question. They wanted the average population between 2000 and 2015. Okay? Because I'm thinking, you're thinking, where's she getting 0 and 15? So that's my 0 and my 15. And then my 6.1, that's 0, 15. E to the 0.012 t dt. And so this becomes 1 over 15. I could bring that 6.1 out front, and now this becomes that e to the kt, so you take 1 over my k, which is 0.012, and I leave that alone. And then I evaluate it between those points. So now you just simply plug all this into your calculator, and I want to show you something. And what do I mean plug all this into your calculator? Where you see a t, you plug in 15. Where you see a t, you plug in 0. And the answer you're going to get is 6.7. Well, if I go back to my original function, right there, and it says the population in 2000, if I plug in 0 into my original function, I would get 6.1. We just found 2015, I would get 7.3. If I average that, guess what? You get the same answer. Yeah. But you'll see this probably written this way in the notes to do it this way with the average formula. And I'm pretty sure that's 6.1. Sounds like a good number. And that's all we cover in that section. That's why I don't really even mention it.
When you plug in the 15 and the 0, you add the results?
Subtract. Yeah, in other words, that's my, well, let's write it as P of X, or my P of 15 minus P of 0. Yeah, subtract the 2. Thank you. All righty, number 38. I did something like this, but it's kind of the way they ask this question, is they say show this converges to 1 over 6. So we kind of did something like this already. And we said, well, you could either pick really, really big numbers, or you could call my infinity b, because that's we're used to the a and b. And so I have this. I could rewrite that as x to the minus 7th, because that would help me remember, oh, okay, that's just a power to add 1. So I'm going to get x, if I add 1 to the minus 6 over minus 6. I'm going to evaluate from 1 to b. Rewriting that is the same thing as 1 over 6x to the 6. If you're like me, you just don't like dealing with negative exponents. So I just rewrote it. And if I plug in 1 over 6b to the 6 minus negative 1 over 6 times 1. Let me go ahead and write it so you know I'm plugging in that 1. Then just like the other one, as you see, we said, well, if you take the limit of that, it's getting smaller and smaller and smaller. So that piece is going to 0. And then we get our plus 1/6, and then that's what they said to do. And when you finish this, though, the first question wants you to leave it like that. I mean, with a plus. So that's the first question, and then the second one says, take the limit, and it converges to 0. There's another, find the area below a curve and above the x-axis, draw the graph. Number 44, it talks about, this is one that I tell students don't use logic. It says a car moves with velocity v at time t in hours by this function. So we know velocity is the derivative, and so there's our function. The first question says, does the car ever stop? Well, we'd hope so. So I said don't use logic here. When the car would stop would be when the velocity equals 0. Can you solve that for t?
Yes.
No.
To infinity, if you see it.
Infinity's not an answer. So in other words, the first answer is, does a car ever stop? No. Okay, like I said, it's kind of a don't use logic type question. Part B says, for the distance traveled, write an integral. Well, from start till we don't know how long it traveled, and then this is just my function, dt. And then part C says to find distances for 1, 5, and 10. In other words, you're doing each one of these separately, but it doesn't tell you how to do that. This is flat out why you're going to have to find either, your graphing calculator will do this. If you don't know how to do it, stay after class because we finally figured it out. Or you need to find an app. I have a link in my notes to a web page to be able to do it. So that at least would give you those options. All right, now we're going to take a quiz.